once if it gets trained, it has to be tested. Now see here. So this is after training. So as I've given here, training, net inputs and targets. So it is taking 17 iterations. Okay, so iterations. Okay, so it will you will have an optimizing parameter. Once if it gets reaches that performance. Okay, if it reaches a performance value or that optimized value, it stops the iteration. Okay, the number of epochs. The number of epochs are fixed here as 1000. Maximum it is 1000, but it won't go till 1000. So if it is going to get the satisfied value after a number of iterations, it will stop that training. Okay, so with the 17 iteration itself, the network gets what is it trained. Okay, so validation check, if you see here 6, which means that it is properly trained, so it is getting stopped after 17th iteration. Okay, and if you see here the training function used here is a scaled conjugate gradient. In the previous example, we have seen the train LM. Okay, so and the performance metrics is cross entropy. In the previous case, we have seen it's a MSE, that is mean squared error. Okay, so this is how the network is getting trained. Now we'll go for testing the network. For testing the network, I'm going to see what is that output is. Output net of inputs, and I'm going to calculate the error. Error is nothing but targets the output. It's actually it is getting trained. Now I'm giving inputs, so it will take input in random and it will produce the output, and then it is going to calculate the error, because I cannot say that always I'll get the expected output. So sometimes that for neural network may misclassify the what is it the input. So in such cases, I have to take the subtraction of the target and the actual output, and let us see that what is the performances. Performance is nothing but you have to use a keyword perform. So here it will generate actually a confusion matrix here by taking your network and the targets and the outputs. Now see here. So out of the total number of samples, this is how the performance evaluation is being done. So here is a confusion matrix. I think you are familiar with that confusion matrix. Okay, so how many actual inputs and how many is actually classified correctly and how many are misclassified. Okay, so if you see here, this diagonal, okay, the green color tells you that the proper classification. So if it is cancerous cell and if it is classified correctly, and this is non-cancerous cell and it is being classified correctly. So here, this is this diagonal is tells you that how many number of correct classification is being done by that network, and this one, this peach color tells you that number of misclassification. Okay, so it may be a cancerous cell, but the network may be classified that as a non-cancerous, and here it may be a non-cancerous, but the network is giving the output as a cancerous cell. So this is a confusion matrix. So one of the important parameters, evaluation parameters, confusion matrix, with which you can evaluate the performance of a neural network. Okay, so this is true, false, and then false, and then false, true. So here, this is one way of evaluating the performance of the network. Okay, again, this is if you see here, so after 12 epochs. Okay, so this for taking for 12 epochs in the cross entropy. Okay, and if you training, and then here it's validation and the testing. So testing, in the testing, if you see here, it is not being correlated correctly. So you have some errors here because of some misclassification are being done by the network. Okay, so here we can create our own network. We can give your own database here, and then you can train the network accordingly, and then you can see whether it is classifying correctly. Okay, so இப்போ நம்ம என்ன பண்ணோம்னா training பார்த்துட்டு trainingக்கு தான் நம்ம என்ன பார்த்தோம்னா we have seen how is it performances. Okay, but we can also go for checking calculating the network performance on the